Hey everybody! I'm back again. Here's a video for week 4 assignment 2 where you are again looking at output and trying to think about this week ANOVAs. So remember last week we did t-tests, and when we had t-tests we were comparing a discrete variable that had two categories and determining whether there's a relationship between that variable and a continuous variable. And so really we were saying, was there a difference between two groups? This week we have three groups that we want to compare. So our discrete variable has three levels, three groups in it, and we want to see if those three groups differ in some level on their continuous variable. In this case, it's how many projects they're finishing. So one way we could go about this, so we've got team A, B, and C. We could do a t-test between team A and B, a t-test between team A and C, and then a third t-test between B and C. However, when we do that, it turns out that our probability of making an error and finding a relationship between them when one really doesn't exist goes up a lot. So it's better if initially we run just one test instead of those three t-tests and figure out first if there is a relationship. Then if there is, we can follow up and figure out where the differences between the groups are. So that one big test is called an ANOVA, and that's what we're going to be looking at this week. So our research question is going to be about whether there's a relationship between team, in this case team is based on the number of years experience, and their effectiveness, the number based on the number of projects they finish. So the hypothesis, let's talk about that. Remember last week we had something that looked like this where we had two groups, and our null was that there's no relationship, and that meant that the two groups are equal. Well, this week we have three groups. But our null, again, is always that there's no relationship between the experience and their number of projects completed. So if there's no relationship, we would expect the average projects completed to be the same across all three experience groups. That would mean there's no relationship. So again, our null hypothesis is going to be that the mean number of projects completed for team A will equal the mean number of projects completed for team B will equal the mean number of projects, I forgot the equal sign, equal the mean number of projects completed for team C. Now it's very common for people and students to look at this and to try to someplace put in number of projects. Like they'll put in here like equals mean number of projects, and I don't even want to say put it in because you'll see it and someone will get confused. So number of projects is already here. So this mu means mean number of projects. So you're saying the mean number of projects for team A equals the mean number of projects for team B equals mean number of projects for team C. So number of projects is already in there. So our null, again, is that they're all equal. Now the easiest way, in this case, we don't have, excuse me, specific hypotheses about which one is going to be higher. We just want to see if there's a difference. So again, here I'm just going to say that our alternative hypothesis is just that they are not equal. And so I can just put in my not equal sign here, and that'll be my alternative hypothesis. And there's my hypotheses. All right, variables we've talked about quite a bit by this point. Your descriptive statistics, again, you're going to describe those central tendency and variation and all those pieces. How many people participated in the study? There you go. Now in the ANOVA, we want to make sure that we're looking again at what type of ANOVA. So this is a one-way ANOVA because we just have one variable that we're looking at predicting the continuous variable. Again, one-tailed or two-tailed. From last week, you may remember, one-tailed means we would have a specific hypothesis about one of these groups being higher than the other. Instead, we're just going to look at whether they're all equal or not. So that's going to be looking in both directions, two tails. All right, after we run an ANOVA, remember I said that we're comparing all three of these groups. An ANOVA is going to tell us whether there is some difference between those groups or not. If it's not, then we're happy, there's no difference, we don't need to do anything else. If it says, well, there is a difference somewhere, then we need to follow up. And we do that with something called a post hoc test. And that test lets us see whether, in fact, the differences between A and B, between A and C, and or between B and C. It could be between some of them or not all of them. It could be between all of them. So the ANOVA just tells us, is there a difference somewhere? And if there is, then we need to follow up. If there is not, we don't need to do anything else. So let's look at our output here for this assignment. And so everything else looks pretty similar to what you've seen in previous weeks until we get down to the ANOVA here. And the big results first will come from this tests of between subjects effects. And you're looking specifically at the effect of team. And just like every other week, here's your value for F. And we want to know whether that's significant or not. So again, we're comparing this to 0.05. If it is higher, that would mean there is no significant difference, that in fact all these means are equal, and we're done. If it is less than 0.05, it means there is a significant difference somewhere among the means, and we'll want to be looking at that post hoc test. So obviously this is less than 0.05. We're going to need to keep going. So we scroll down a little more. Oops, sorry for the scrolling there. Here we go. So here's a graph that's going to start to show us. This isn't the post hoc test itself, but it's going to show us what we might be looking at. Group A finished just over 3 projects. Group B finished over 7 projects. And Group C finished just under 3 projects. So if we're looking at which of these teams have differences, we might say that B is higher than A and B is higher than C, but maybe A and C could be equal to each other. And that's what the post hoc test is going to test, those hypotheses. And so what we're looking at here is in the next section down is these post hoc test analyses. And so this is going to be the comparison, and I like the Tukey HSD right here. This is the comparison of each team with each other team. So here's the comparison of team A to team B on the first row. The second row is the comparison of team A to team C. That's this row. Okay, now it gives all possible combinations. So the next row is team B to A, and you'll see that's just exactly the opposite of A to B. These are the same numbers. You don't need to report all those. But we haven't yet seen B to C. And so B to C is this 4th row right here. So what we want to look at is just what we've always looked at. Is this difference significant? So is the difference between team A and B significant? Is the difference between team A and C significant? And is the difference between B and C significant? So that's what you're going to be looking at to find out where those differences are that the ANOVA told you was there. All right? So based on that, you're going to tell me the results. What conclusions can you draw and not draw, and what issues do you see? So I hope that's helpful. And again, please ask if you have questions.